Right. In this little stream session, I'm going to try to fix the second attack vector from the gun in 360 seconds by rule Milos or Flavio, Garcia, and Balash. That is implemented in RFidlib by Kevin Sheldrake. So yeah, that's what I'm doing. I'm trying to modify Kevin Sheldrake's code into a proximal world. Let's see how that works. You just gonna see my left screen the whole time. Not doing anything else. Kind of annoying though, but that's alright. Turning off this thing. Right. So the concept is start off, you already get back, send NRAR, ignore that, and we get this data here. This is already encrypted, ignore that, and then send the long page 0 command. So we know we're going to get the encrypted UID again, so we can recover the keystream data. And this here is going to be prolonged, so we're sending a 248 bit, or 210 bit, 2010 long bit command to recover it step by step, so increase it. So that's what we're going to do. And I'm trying to simplify it all on that part. So this part works. We get that because that comes from this first vector. This is the second one. And now let's see what happens. I hope the sound is good enough, but you never know. Anyway, command length. Okay, offset. Need the SOR. Start from there. Got the key bits. And there's no offset. We're gonna encrypt all of it. And this is the new number where it's long. There's no offset. Should be keystring length, I guess. And then we're going to send keystream. Let control keep the field up. No, you can actually turn off now afterwards. And if we get a response, we should be able to, yeah, this is the issue. Case length. I wonder if this is correct. This plus 40. Why is that? Let's see. Let's add 41. Well, no, this will work, but we can try it at least. No. Okay. M and offsets. All right. Yeah, I don't need that. We're not. Look at M, so it doesn't matter. All right, let's do that. Hey, run failed. Have I messed up the repo again when I do this? What did I mess up now? All right. That is not good. You know what this is? This is stack protection. Let's not do that, shall we? Where is that from? Where is that from? Yeah, okay. How about we don't do this part one yet? How about we don't do this yet? Alright. This is just completely bonkers. Like, okay, we have done those. Enter. All right, so we add on this one there. Just for the fun of it, we can take a quick look. Give me 80, 160 of them, thank you. C2. What are you complaining about? Oh no. What are you complaining about? I take Crack2, okay. Alright. Where are you? Green command, okay. Okay, that should fix the building on the repo. Please no. doing this. Alright, extended fail. So we're sending this. We're sending that 40. From 0, we're sorting that one with key bits that we have. We're sending those. We're sending 40. Right. I'm going to add those. I'm going to add 40 keystring bits, but I'm not sure about this. As we add by 40 and we only add those. Hold on. This seems wrong. I can tell already. This seems wrong. But let's ignore that and run it again. Let's ignore that and run it again. Where is running? Alright, this looks good. 0100, and that's invert, and then it starts again, and that's invert, so that's good. Good. And then it comes here, and then it fails. Great. So far, so good. Yeah. Should be Pi hacks. Hello to you too. No, everybody. All right. I was for 2 weeks back. Yeah, I'm chatting with Kevin Sheldrake as we talk, as we speak. Yeah, okay. All right. So for those of you who do follow, you can actually pull the code at the same time and try to do the same damn steps that I'm doing right now. Oh, let's see. Wow, let's see. Come on. Hard to see these things here. Let's see. Why is it comment? Why is it comment on this side? I have to do this. My current work tags are highlighted too. Hey, look at that. Yeah. What will Crack2 be able to do? Wow, you don't know. Crack2 is the second attack vector from the Gone in 360 Seconds paper. The original paper from 2012 by Rule, Flavio, and Balash. Where they introduced 2 attack vectors. The Crack2 is the implementation of that one by Kevin Sheldrake in the Iceman Code. So you will extract or prolong the key recoveries of bits, key stream recoveries, so you get 248 bits of key stream material, and then you run. So that's the online part. It's a time memory trade-off attack. So people, with the 2048 bits of key stream that you have, you will take that and you do an offline mode, which is where you have generated these tables, 1.2 terabytes of tables. It's like a rainbow table. And then you run your 2048 bits and recover the key from there. And no, I do not have those 1.2 terabytes of tables built, because I don't even have the key material yet, or I can't recover it yet. I can with my R-Fiddler, but not this one. Does that make sense to you? So just a lookup. I don't know how long that lookup takes. I will have to ask Kevin Sheldrake about that. He made some excellent presentation at 44Con 7 years ago. It's 2 talks. You should see that one. You should definitely look at it. You used Mig Ink 2, great work. Particle. So you did that now. You did check. Cool, I like it. Which key did you get? Because I'm collecting those keys now, so those crypt keys. Please just, you can DM me on Discord or whatever you want to do. But yeah, feel free to do that. Hi, Alexander Arnishev. Sorry if I mispronounce your name, but yeah, right, cool. So now I just need the link to this stream. Send it over to someone and hope that they will join. Here you go. So if you get, this would be fun if it does actually. If it does, we would get Kevin Sheldrake to join us. Would be fun. Okay, default password, yes. In password mode it is for this. And writing down to the card. Don't know if we have any write yet in that sense. You need to store, you can write individual blocks. Normally, if you look at the reader info command, you will see that it is, if some blocks are locked or write protected. So normally blocks 4, 5, 6 are write enabled for you. But you can, depends on the configuration of the cards, what it is. But normally you can, if it's like a Pakistan or something like that, you can do if it's password mode, you should be able to just make well, not a downgrade, but you should be able to take the data from those user memory pages and put it on T5577 instead. Yeah, here we go. That's right. Yeah. Keys stored in me from MCU of cars, CS bytes in the real world, unique in this case. But I reach out with some research I'm doing. Cool. Migging 2. Cool. Yes, back to the code. So these steps, I don't know if Kevin is watching this, but if he is, I'm going to take this one down. Okay, do like this instead. Thank you. Okay, offline. Thank you. I used Proxmox to sniff my setup. So the steps are wrong. This is wrong. Hey, we got Kevin Sheldrake watching. We got the famous guy watching. It's amazing your research about everything, and I think it's awesome that you actually can try help me. So yeah, cool. Let's go back here. The thing is, since I know you're watching now, this is of course wrong. The steps here I'm doing is wrong because I'm not doing it correctly, right? because I'm not doing it correctly, because we're taking the key stream, which is from the beginning of it, right? And we should XOR in the response to get the key bits from the end of it, and not plus 40, right? So I get 32 bits of key stream. Yeah, K-sling is plus 32. Yeah, it shouldn't be 30, 40 like that. Yeah, because this is what you do, because I have two gigantic arrays instead, so I did this just in case. And I don't have any limits. The Proxmox doesn't have any limits by sending, so we are sending the bits. We don't, you know, it works like that. So yeah. Yep. Let's see if that works better. Let's see if it does. I owe you 2 beers. If you come to EMF camp, we can have some drinks. What are you laughing about? I'm dead serious. I'm going there end of May. you should get a talk accepted. Everybody will listen to you, man. Of course you're gonna get accepted. I got tickets, so that's. I try not to talk. See, this is the encrypted thing. This is not encrypted thing. This is just the extended command, so that is correct at least. So this is extended, and then we send UID and this blah blah blah, and we turn off the field here. I'm pretty sure you're gonna get your talks in, man. Don't worry. I'm looking forward to see you there. I submitted this, but we start from this, and then we take 72 bits in, and then we send 72 bits. Right? Okay. Don't send 72. Ah, no. No. Send 70. Okay. So it's case length -2. Why -2? Or is it -2 for every iteration? Attack is running. I don't know. I don't know if it works. Command failed. Didn't work at all. That's what I can tell you. Right. Let's set this up here. I'm doing this because sometimes it's easy for me when I do this, and I'm gonna do this. I'm gonna do sniff that. Okay, let's split this up again. Do this one. We'll do that one. You there. You sniff and you run. And okay, that's completely wrong, of course. Config trig 50. Skip. Ooh, skip 5. Skip 5,000. Why am I? Whoa. Where am I? 13? Oh. Okay. 4,000 data plot. Alright, cool. Let's see what is happening here. Wake up, off, URI off, and then sending this. Don't get a response, okay? Here, got a response. Not getting a response. Here we got a response. Okay, cool. So that worked. What happened? Okay. I don't know. I don't know. Oh, cool. Thank you, Cineford. Mind if I put it in the in my default password key list file? So send URI, waking it up, and we turn it off there. We send this, ignore that one. We soar. We can actually do this before we start this, by the way, because this will take time. So how about we don't do that? How about we do that first instead? Awesome. Thank you, Cineford. I can do that. Let's see. Ignore that one. In with that command. So great. So we send that, ignore that, and now we're sending this, and we send kstream -2. Okay. I'm gonna go here, and I'm gonna go. Here we go. No, we're gonna do this. Here's length. So it's not even 30 here. It should be 40. I'm not sending 72. I haven't added. So you said the first time is at a 40. Should add a. Should send. Totally confused. No, I should send. No, thank you. Yep, quit that one. Take you offline because otherwise it would be annoying. Yeah, of course. Whoa. Okay, one again. One time again, like this. We have 40. So we start at 40, right? We start at 40. Boom. We assume that. So I don't think we're gonna send. Yes. Make that 42. Make this one 42? Okay. And then keep -2 and all's good. Alright. We've got some logic there, man. Try it. Yeah. Did it enter the loop? You see here, enter the remain loop. So yes, everything until here means that the crack1 worked. So this is your loop, the crack2 loop. Is running. Now it's main loop. No, I'm telling you, this is. Why is that 74? It's because I had keystream here 32, so we have 42 up there to start with. And then I add the keystream 32 up here in the end when I loop around. Make that 30, okay. Oh, let's make that 30. I don't know. You're the boss, man. Should be drunk doing this instead. Hello to all the 5 other viewers. Let's see. Does it work? This is a weird pair program. I fucking love it. Here, look. Recovered 72 bits. Keystream is done, and it fails. Okay, so now I'm gonna go in and do the sniffing again. And now I'm gonna look at data. Look at it. Green S4, okay. If you don't know what I'm doing, is that I have an extra proxmark that I try to sniff this traffic, and I do that by doing this. Trigger at 50, skip 500,000 samples, 500,000 samples. Yes, and let's sniff. Data plot. And then I'll do this. And I go that, and I do this. Run that one. Hey. Let's sniff. Damn. I'm missing it. Come on. I missed it. Okay, one more time. Sniff. Run. Alright, cool. Alright, cool. Off. There's a useless thing. We're sending this. And that's the first encrypted command, and we don't get an answer if I get this correct. Alright, let's do this again, and we'll do that again. Okay, let's do that again. Now we'll do this. Short. God. 1,000. Millions. Boop. There you go, thank you. That sniffs 1, 2, 3 now. Why are you in Trackton? 4, 13, great. So, I got a good sniff. Yes, look at that. It looks like much better. We're getting the end. Here we go. Hey, look. It did succeed. So this is the encrypted sending command, and that's okay. Great, so that worked. That's odd. Well, that is odd. Why did that next step didn't work then? Because this is the extended read. This is the 42, yeah, okay. We're sending 40 bits. Yeah. So, okay, yep. Okay, K-stream has to be multiple of that. Okay. Mm-hmm. Let's see. So we did this, and we can do that before we're sending anything. Let's do it here. Yeah, that doesn't matter how we sort it in, so that doesn't matter at all. XOR is on line 3080. No, it's not. XOR is here. This is the main loop. There's. What do you mean here? No, no. No, you're looking at the wrong place. You're looking in these ones here, I guess. Yeah, in the extended one. Not using it anymore. We're like doing it from the beginning all over and over and over while you are doing it with an offsets. The one that decrypts the PO. This one? You mean this one? 580? Yeah. And? Tell me more, Kev. I want a -2 there as well. Ah, makes sense. You should call. You can call in. And do you want to be in the stream, man? You can if you want to. I don't know. Depends if you have Discord or something like that. Hey, look at that. Got a key. Crypto authenticating. That looks like you were using some old code when you did that. But thanks for that key. Right. Okay. So you didn't do that because of DB string. Sorry. Whoop. Doing it wrong. This was not worth it. DB print. All right, let's do it again. This is why, developing on a Proxmark is not always the easiest thing to do. It takes you time and time again by flashing and flashing and flashing. Sounds like the old school C programming with debug statements. Oh. Let's do that again then. Let's not do it in... Oh, I know. Quit. Thank you. Remove a banner. To speed up the boot. The banner is flashing, man. That's me flashing the device. Yes, I'm ego tripped. That's why it says Iceman on it. And it's bleeding edge. Let me see it. The bleeding edge. Alright, let's put the card on the antenna. Alright, cool. When I forget to do things, it looks like that. So, do this again. First one works, and when we send the second one, we're failing. Okay. Second one is failing. So (72) means that we're sending 70 bytes here. We sword the whole damn thing from beginning to the end by this amount of by 70 into this one. So we took that one and we took those and we did that. So this one has been, it's a little bit stupid way of doing it, but it works. Should work. So this works and this works. And then we send this extended command and we send it 70 bits. And it fails. Why does it fail? Because the first time it means that this is the problem somewhere here. These two lines must be the problem. The decrypt or encrypt is wrong. Well, I've sorted in like we do here. This is just the extended command the page 0 reads, that we then add the key bits to again and again and again from 0 to that length. Alright, so we all matches up. That's a very annoying way of doing it. But yes, so we just keep on copying. Oh. Oh. Yeah. No. Nope. No. Oh, wait. No, this is just the key bits, okay? So we have a key bit stream there. And then we build up the extension with a normal plain read page 1 commands up there. So this whole thing here is just filled with plain read page 0 commands. This one. So the key bits is the key bits we can use to encrypt. So I thought that if we take that, we can encrypt this one, and that ends up the encrypted command will be in here. So we don't decrypt anything, we just keep on expanding the encryption. Fuck. Can you see my code now? Alright, let's do it again. So up here, this is the main loop, right? So here I just make let's read page 1. This is the plain read 1. And we put that into here. So we have a whole heap of extended commands in plain text. We should just say plain extended, right? But it's not, it's called extended. And then here we have a key bits. So as of 0 to keystream length, we have key bits that we then encrypt all of those here, those plain read page 0, and we get the encrypted reads here. And then we select the UID and do the NRAR, and then we send keystream -2. We send 70 bits of extended command, right? So we send what we encrypted up here, and if we get a good response, we store it with UID 32 bits, and we add those to the key bits. This is wrong. This must be wrong. So this is 42, 40, and then we add 40, 72 here. It has to be wrong here, right? It shouldn't be -2 here, right? Because this is an offset now. This is an offset to in key bits, which we recovered. We recovered 42. So we add 32 to the 42, so we have 74 keystream length, but we only use 70 of them the next round, right? I think it should be like that. Let's see. First param should be after. What? The first param should be after extended. I don't know. Let's see. Yeah, this is wrong because we add 30. No, it's not true because we add 32. So this is wrong. No, we have to add 32 here. We add it on top of it. Boom, boom, boom. But we're not sending it like that. We are sending it. Yeah, we don't have an. That's what we don't have. We don't have any unused bits. Right? Yes. So, okay. Great. So we start at 42. Boom. That's what we have. Mm. 0 to 41. We add 30. we can ignore the two last bits, but we are adding them here. So either we, when we add it to the C2 key bits, in either you want a complete set of keystream with 42 plus 32 plus 32 plus 32 plus 32 plus 32, because that's how I thought you meant that it was, or we have jumps in, or we have skips in the keystream. 42 plus 30 plus 30. Yeah, we don't use for keystream. No, it's true, right? So we need to, we just, okay, so we have 40 bits, all right? We have 40 bits first then. Let's start like that one. We have 40 bits of keystream. Cool. And it's in the C bits part. Yes. Yes, we start at 40 because that's what it is. This is why we're not doing this correct. And then after each run we get 32 bits, right? But we're gonna send, this is okay because that's what we add, but we can send plus 32 equals 72, we can send 70. And then we have 104, 72 plus 32. We have 104. We can send 100. Yes. No. Okay, so you mean it? So we overwrite 2 bits of the keystream in keystream that we're saving. Man, okay. But we only extend by 30. Okay, so we don't add those. Okay. Then this part here is dodgy then. Okay. Because if I set, here's the thing, if I set $40. You do the same problem as I have. That's correct. Yeah, it sucks, man. It's a kind of one-way discussion as well. If you do, you can call in on Signal, and I can have you in my ear. You don't have to type it if you want to. Don't. I can mute that part, so you shouldn't. Your voice shouldn't go out. Hey, brother, how you doing? It is, but kind of fun as well, isn't it? Well, did you get a roundabout now? Because your voice should not be on the live stream. Yeah. All right. All right. Yes. Yes. Yeah. No, you should see my code now again. I changed it back. Sorry. So I took away my big ugly face. Yeah. Mm-hmm. Mm-hmm. Yes. Yes. Yeah. 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 Yes. Yes, but we overwrite it here. Yeah, that's what I mean. This is because we are now off by those 222 things. So this, when we add key bits here, we're overwriting the last two ones. Because yeah, that is our problem. So we should actually add 2 here. Yeah, we did. Yeah. 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 Yeah, it starts from the beginning. That's the problem here. That's what I mean. We always start from the beginning and build up the whole key. Is that okay? Yeah. Yeah. I will sort it out with offsets. I just wanted to make it work the slow way, and then I will do an offset thing next iteration of it. Yeah, that's what I'm saying. Let's go for it. Hold on. While you're looking at the fabulous logo. Yeah, I know that guy. I know them. He's a dumpster fire guy. Yeah. He's a He's a badass. He's a real badass hacker. That guy. He's a really badass hardware hacker. That guy. You know the Softlock hackers? Buzzes was on that guy. He's one of that team guy. Yeah, yeah. It's the Unsoftlock guy. Yeah, he's on fire, man. Yeah, yeah. This is where we're doing that wrong thingy. I'm gonna go back to your code again and see what's. Because you do offsets. You just add an offset all the time. And that offset is correct. While I'm trying to do it from beginning, and it's like I'm failing it because your offset should be working instead. So how about we use your KS offset thing? Remember? Do you mind having your voice call on the stream? Because people, let's see if it works. If you say something.
Okay, yeah. Can people hear that?
Can people hear you? Can everybody hear Kevin now?
Hello.
It should be okay. I can increase his volume like this. Talk a little bit
I
more.
can turn mine on and then I'll hear if I can hear myself coming out of.
Can you hear yourself now?
I can turn mine on. Yes, I can.
Perfect.
Yeah. Okay.
So introduce yourself,
everyone.
Kevin.
I'm Kev Sheldrake. You can find me as RTF Code elsewhere, and I wrote the Crack2 crack for R Fiddler some time back, a few years
2017,
ago
man.
Yeah. So you probably so I did some talks about it, and me and Iceman have spoken before about trying to get it into Proxmark, and it's all extremely difficult. But Crack1 is there. It's very impressive, and this should just follow on. Like if
that's what I'm saying too. We should just work, and I'm like, oh god, it's like, oh. All right, let's.
So we could print out the key stream, and we could print out an encrypted command. If the creation of the so the encrypted command should be fine, shouldn't it? The unencrypted commands, the 2080 bits of unencrypted command, that should be correct, shouldn't it?
Yes, no, that's just
that one.
That's just by tens, So this is just we do it once and that's it.
If that was wrong, then the 40-bit
that would fail.
Would fail.
Yeah.
Right. So we trust the plain text command is right.
Yes.
So the encrypting of the plain text,
but
we just use the key bits and up to 70 bits of the key length. Yeah. So maybe we need to print that out if we can.
Because I'm doing that from the beginning, right? So we go from 0 to 70 then next time, remember? So
yeah.
Okay, so we can print it out then, so it's no problem.
Because when the first 40 bits is right, but the next 30 bits is wrong, which makes me think it's the decrypt that's incorrect.
I think it's something with offsets that we do something wrong with 2, so it just increases and then
it's definitely the 2, yeah.
Yeah, something with a 2 that, when we add on. Because this is how many we send, so this is the sending of that extended encrypted command.
That should be 70 that we send.
Yes.
And then the next 32 bits would be what decrypts what was used to encrypt the P0, which is the UID, which is there.
Yeah.
And it looks right, doesn't it? I mean, that's the thing.
Looks right, but still not. So yeah. Let's see. Oops, that's not working. Offset. Okay.
Maybe we should print out that. We already got. But maybe we should print out the response, the encrypted response.
Unencrypted. Oh, you mean here?
Well, I'm thinking around line 580. You've got the hex to bin array.
Yeah.
Somewhere.
Oh, we can do that.
Yeah. Why do we do the hex to bin array? Is that
It's because you guys in the RF work is working with bin arrays with zeros and one. You're wasting 8 bits of data for 1 bit of information. So yeah, so I took that. So this is why we have bits. That's why we're using bits array everywhere, or binary arrays, and really wasteful of space. But yeah, that's how it works. And I didn't convert it into bytes, but we can do both in the
but maybe the error is here. But because we send the 40-bit command, and if what we get back we treat incorrectly, we'll never get the next 32 bits of keystream, which means that it always fails. So maybe it is here. It's somewhere in these lines where your cursor is.
Here it is. It's somewhere here. Yeah. So I will print the response though.
Yeah. So is is Hightag2 Crack2 or using this bin array malarkey?
Yeah, this is the bit stream. This is the recipient, the destination. This is an in source, the response, and then we take the UID, and it's 32 bits, and it's inside this. It gets pasted into C bits on that offset and forward.
Right. Oh, I see. So Proxmark deals with bits correctly. Our fiddler uses 1 byte for every bit because it's a faster.
So I'm doing the same way. That's why we're doing it to bin arrays. That's why our fiddler does it in bit arrays where you have 1 bit is 1 byte. So I do the same. So 0 and 1. So I'm doing the exact same thing. So that's why I'm wasting a lot of memory in the Proxmark world right now in order to.
Yeah, I think it's just because it's fast, because you don't have to mess around to get each of the bits. But I don't know. I didn't. I mean, it wasn't my decision. That was something that Adam had done.
I would just take the memory bytes and XOR it, and that's it.
Yeah.
You don't have to do it bitwise. That's why. All right, let's see. We're running. Nice seeing you, by the way, Buses. Here we go. So this is the encrypted response.
Your audio is one way only.
No, it's not anymore. You're fine. You're good.
Oh, okay. So we still failed. Right. Okay. So
we get that. So we get this. This is the second loop.
Yeah.
So you see, this is the same as we're sending until here.
Yeah.
Over there, that's the same. And then you see this is the plain text. No, yeah. And when we send
it should be there.
The second time around, it doesn't work. Oh man. Don't you have anything useful to do? Don't you have some, hacking event to do? Let's see, up here. Here. So that's the crypto bits, yes. So crypto bits this is the crypto bit stream, but recovered, and this is encrypted. Okay, let's print we just added to it, so it looks like we added correctly. 1 2 3 1 2 3 1 2 3 1 2 3. So we added this, and we would need to have. Okay, we need to do that separately to see what happens.
So if we maybe we print out. Yeah, we do. Yeah, dumping it there. Yeah, that's good. And then after the XOR, maybe we dump it out. I don't know.
Yeah, we'll just.
I don't know. I mean, my general approach to this kind of hacking is to print out as much as I possibly can, and then with a piece of paper work out what I'm supposed to do with it.
Then we are 2. Fancy debuggers,
Yeah, exactly. It's 2. That would be neat if you could connect GDB to the Proxmark, but then I suppose
you can apparently over J-Link.
But it messed with all the timing, wouldn't it? So nothing would work. maybe.
All right, so now we take the recovered key stream and we can look at it, okay? We should see it appended to the key stream bits in the correct place.
Right.
I think we're overwriting 2 bits, that's why, in the key stream.
I think we're supposed to. I think when you
Well, if you do that, you mess things up, don't you?
Yeah, I don't. Because we go back to 0 each time, because we start from initialization, because that's how we know the PRNG is in the stable state.
Yeah.
When we get in, if we send we'll send 40 bits. I mean, then we get 32 back.
Yeah.
We can only use 70 bits of that key stream. We know the next 2 bits, but we don't need to use them.
Yeah.
So it shouldn't. I don't think it should matter. I don't think so. What have we got? Okay. I've got up and walked around, so I was like,
oh, no worries. Here is the recovery key. That's the response, and this is the crypto stream bit. So it starts like that, and this is what we had. This is this crypto stream that we started with, and that ends there. So we compared from here, and this 011001011. 110010. Yeah, it matches, right? So we got all that.
Yeah.
But you see here is wrong. You see?
Yeah.
Yeah.
What's going on there? Hang on.
Hang on a bit here.
So
we're missing 2. We are missing 2. We're missing those 2.
So where's he? So
yeah, we only
are these 16 bytes wide? 16 bits
look. No. We are having keys in 40, and then we have 32, but we only print 70 next time, right?
Yeah.
Yeah, that's why these 2 are gone now from the key stream that we're trying to generate stuff, right? Because we're sending 70. So we are using this key stream here, 70 bits, but we have 72.
Yeah. Yeah, that's right. So we're using the first 70 bits of the known key stream.
Yes, exactly. And it looks correct to me.
But the command is clearly failing, isn't it? Oh, tell you what. Could you only use like 50 bits of it?
Sure.
And see if that worked. Or just do 40 bits. In fact, the second time around, so where you have the send KSLN on line 567.
Yeah. How about we just send 70 or?
What if we don't? What I was going to say was, what if we only sent 4? So if we make sure the loop ends, because obviously the loop won't end if the KSLN doesn't increase. But what if the second time round we just sent the first 40 bits again?
Okay.
That should work. There's no reason why that shouldn't work, is there?
Yeah.
So we just don't increase the key length, and instead we just brilliant.
All right, so let's do it. So we know it's just going to work once. So the first time this works, it's going to work. So yeah. So kev factor here, and now we lock it down to 40, right? Or do you want 50?
Just do 40? Yeah, just stick 40, hardcode 40 in there, and or 50, 40 or 50. I mean, 40 should definitely work. If 40 doesn't work the second time round, then it's definitely broken.
Okay, so we need to break this loop.
And then if 40 works, we move to 50. And if that doesn't work, then we need to seriously look at our crypto bits, I guess. But this will get rid of. This will remove the question of are we overwriting bits or not. All we're trying to do is like just use the existing crypto bits that we've got.
Yeah, I'm just gonna add a button press because I will need to interrupt that loop.
Yeah, that's that. But that's what I'm saying. You need some way of stopping the thing.
Do UK Unix system run with init? That's a good joke, though.
The UK Unix systems run with init. Oh, okay, init. Yeah, okay. Fair play.
I think that was great.
Yeah, why not?
Oh man! Look at this. Look, it's working.
It's working. Oh,
yeah, look. Pop, 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 working. It's
right, so
hard-coded 40-bit works. Yeah.
Okay, so 40. Okay, so then let's make it 50 bits.
Okay. Boop. I like the way you're thinking. Same old school as I am.
Yeah, just a good because if we can minimize where the problem can possibly be, maybe we'll find it.
Yeah, for sure.
And then it'll magically work, and it'll be just amazing.
Let's see what happens. Let's do 50 now, man.
What am I supposed to do something this afternoon? I just
nothing. It's late for you now, isn't it?
I'm just doing.
Look,
this
it works. Look.
Well, it's not failing. You mean? Oh,
yeah, it keeps on running. Yeah.
Oh, okay. So 50 works. Let's go to 60 then.
Yeah, let's do 60, man. Somewhere.
Well, you know.
Yeah, I feel you. Let's flash some, man.
I mean, the joy of crypto is that there are no like nearly answers, are there? It's either yes or no. It's
very Boolean, yeah. I think it's beautiful with people doing this stuff and we pretend that they make it in the first try. I'm like,
yeah,
fuck off, you fucking wanker. Yes, failed. Look.
Oh.
Here. So we hard-coded 60. And it failed. That is interesting.
But 50 worked.
Yes.
So the first 10 bits that we decrypted produced a key stream that was correct.
Yeah.
Mm.
This doesn't make sense, so let's go for 58.
No, you can't. It's got to be in fact a multiple of 5.
10, yeah, right.
55 would be okay.
Yeah.
It could be a multiple of 5.
Yeah. Because
it can be. It can. Technically, it can be a multiple of 5. Because each command is only really 5 bits. It's just that you have
the inverted one. Yeah. How long does it take on our fiddler to run this attack? Because finding the page 0 first one is the one that takes time.
Oh yeah, it takes longer than that. It's like a minute. I don't know, 40 seconds, 50 seconds. I can't remember. Something like that.
So that failed as well. Interesting. Okay, so 50 then.
50 seemed okay.
50 seemed to be okay, yeah. Let's go for 50 again, see if it worked. Interesting. Are my encrypted commands wrong? No, it can't. Why should it? Why should it be like that? For all of the other viewers up there, please let me know in the comments what do you think about things. If you have any questions for Kevin, Kev Sheldrake, the amazing man, you can just type it in there and he will happily answer it.
Yeah, I do. If anyone can see the bug, then you know,
if you do that, that's okay as well.
Yeah. Oh, so is that okay? 50's okay then.
Yeah, 50 is okay. It's just just increases, right?
Okay, so
what is going on?
Right, so if the first 10 bits is correctly decrypted,
is it something wrong with you? No. Wait.
Oh, yeah, what's going on? We're doing it twice. No, that's in the temp. That's okay.
That's okay. I'm just gonna verify that. And
you might want to. It might be worth checking the generation of those extended commands should be right there, shouldn't they?
This doesn't quite make sense, to be honest, because it's here and it's this. I made a loop, made this. Wait. So here 0 0. This is inverted.
That's
so
right. Well, it'll have to be right at least once, won't it?
Yeah. So
otherwise
but by the way, I never gotten this response though. So this is something I have no idea why you do this, because I have never gotten this ever.
Yeah, maybe that came from. I wondered if it was an R fiddler side effect.
Could be. Yeah, it could be some,
it could just be an or a specific uninitialized buffer or something that it returned.
It could have been like that. Yeah, because that one threw me off as well for some time.
I'll tell you what, it might also just be. It might have just been a feature of the Hi-Tag 2 read-write device that I was using.
Could be. I don't know.
No, because it's a tag. It's part of the tag. This is the tag we're complaining about. We're hacking. So, yeah, weird.
So that would have been maybe
it's an R fiddler thing. That's the best guess I've got.
Must be an R fiddler. Maybe a buffer that wasn't emptied, or it returned just.
But it always returned the same number when nothing was in it.
Yeah.
Which it's quite possible, I guess.
Could be. You never know. You never checked it. Not that many people running R fiddler nowadays, are they?
Yeah, unfortunately not. But
all right, let's see. So we get 32, so it's nothing with the n value, and we're getting. This is the encrypted response we get. Is it matching this one? Yes, and we recover.
Are we getting the same encrypted response each time? Yeah, we should be, shouldn't we?
Yeah, let me see the UID on that tag. Yes, really fast. I'm gonna look for my UID. HFI tag info. Data num hex, and then we're gonna look at this one. So this is my. Yeah, but it's sent in that reverse damn order, isn't it? Card UID. Let's compare it with things. Okay, let's go. You can do it here instead.
I mean, we're still seeing the Proxmark screen at the moment.
Oh, yeah.
There we go.
Should be available now. All right, let's see. Card UID. My card UID here is this. All right, cool. And what are we seeing as the response? Here, when do this. And we're going back in here, and we'll look at this. So encrypt the response. Recovered keystream bits should be the UID then, right? Right, so. But is this reverse order again, or what is this?
I mean, it's not, is it?
It's not, is it? Right.
I'm guessing. Well, I can't see those 4 zeros in the second block, for example.
No. Neither can I. I see this, but that's not inverted. What is this?
Oh, yeah, that was right. And there's a... Oh, that's all the way back there.
Let's go. Is this all right? Okay. H 0 1 1. No. Thank you. Why doesn't do it in the damn Visual Studio Code? I say it's nothing. Selection, replace all. Thank you. Copy. Should be yeah, I don't see the UID there. Even if I pretend really hard.
No, exactly.
So, we're not recovering the key stream then, because we're not. No, oh fuck, this is wrong. No, this is wrong. Oh, wait. You. No. Here. No, that was. Where do you recover a key stream? Is.
Yeah, something like that. So, so it's basically immediately after the commands you've sent. So, however much you've sent in the commands into the key stream, and then you XOR it with the UID.
Yeah, so that's wrong, basically.
What's that?
So it's wrong. We're doing this recovery here wrong.
Are we?
Yeah.
Well, yeah, we are, but clearly, but but do you have an idea of why it's wrong?
Yeah.
I mean, I've accepted the Proxmark saying it's not working.
You're killing me.
So
I need something to drink for this. Oh, man, this is too funny. So clearly we are actually doing in the end of it. See, we not end of it. We should be back, right? We should be
key bits starts.
Yeah, no, this is the 50 as well, so of course it messed up. So yeah, no, okay, this is your 50 bit version.
But there's that. Then that KS length should be 50, shouldn't it? Obviously, if we're doing the Kev version.
Yeah, exactly. So that was wrong. Let's.
But we could probably, you can probably go back to.
Let's remove a Kev factor, shall we?
You can.
Yeah, it's okay.
Yeah.
All right. Cool.
Lose that.
I'm gonna drop this. I'm sorry for that. We're doing that. Right. Key stream is what we're sending. And now here's the problem is because we're taking to decrypt the response.
So just to get
we have an editor. Oh yeah. Okay, that's okay.
So key bits is what we use to encrypt the command, isn't it? From the start of key bits.
Yes. It's the crypto stream, yes. So,
yes. Yeah. But specifically from the point where
so it starts from the beginning all the time. So it
starts from there. Exactly.
Yeah,
right.
So it starts from the 0, right? I mean, keeps on adding it. It becomes longer and longer and longer. Here. Right.
And these are all like bit arrays. So each byte is a single bit. Yeah.
Yeah, it's a byte. Yeah. So it's okay. Those are okay. Yeah. So we can see the C bits up here. The first one in in oops, it's gonna be a long one. Here. So this is the first 40 bits that we have in the crypto stream, and then we recover.
So
and now
time,
we have 70.
Each time we should see the same. That same should be there, shouldn't it? Up until where it 111. Yeah, it's about. That looks right, doesn't it?
This looks, this is good enough. And then here comes the new one.
Yeah.
And that would be, this is this. This is recovered once. And it starts, yes, let me do, let's do this. And we do.
And then it's plus 30. It's added 30 on the end, which is right. It's just. But yeah, what we're getting back is.
This is this is an encrypted stream, so we can look at it a little bit like that. It's easy. And this is what we had before, right? So now we have the same thing, but with some extra here on the end, and those extra should match up around here. They should match up, right? If it's correct. Yes. So they match up, right? I'm missing those two there in the end because we're just printing 70 because this is what we use in the next round. But we.
Oh, hang on. Why? Yeah.
Oh, yeah. No. Okay, I get it. Oh. Yeah, because we're overwriting. This is what I say. We are overwriting 2 bits of a keystream every loop with a Kevin factor. This is what the problem is with it. It should be +2 here. Oh, +4 and plus. Yeah, we need to add 2 steps.
No. I don't think so. Because if you imagine that the PRNG just generates this keystream.
Yeah.
And
hear me out.
The RWD saying sync, don't they? Yeah, go on.
Hear me out. So we get 70 bits, right? We use this. Next time we start wrongly overwriting the keystream bits by overwriting the 2 first ones here. This is what I mean. And we start. Here comes the new one next time. So we're overwriting these ones here with a new stream. Oh, we're starting here with a new one. So we're overwriting 2 bits every loop.
Yeah, but they'll be the same. But they will always be the same 2 bits. No,
because we're building a long stream, right? Long string. So we need to add 2 here.
No, because we haven't used this 42 bits that we've got already. So we sent 10 and got 32 back, didn't we?
Yeah.
Yeah. And so because we know what command we sent and we know what we got back, we can XOR that, and then we end up with 42 bits of key stream. But then when we send, we can only send 40 bits of encrypted content because it has to be a multiple of 5.
Yeah.
Or 10, right?
Yeah.
So we make a 40 allegedly. We make a 40-bit buffer with our command in. We XOR that with the first 40 bits of the key stream.
Yeah.
And then the tag XORs what it receives with its 40 bits of key stream, and then the next 32 bits of key stream is what it encrypts the UID with. So we receive a 32-bit encrypted number, right, or 32 bits of encrypted data, and we're 40 bits into our key stream at that point, and that's when we XOR it with what comes immediately after that 40 bits of key stream.
Yeah, which is okay.
Which is what we're doing. Which is I think is what we're doing. That's what I.
The first time is okay, but the second time.
Yeah.
Then we added to.
On the second one, we're failing at 566. It's on the first run when we're failing, if we're failing at all, isn't it?
So the first time is 40, right? And then KSL is 70. But this is what I'm try
I know,
to...
but we don't get that far when we're 70, because when it's 70, we fail at line 566 on the TXRS.
Yeah, I know. But I think it's because we overwrite in 2 bits of data, 2 bits of a key stream, that's why. So this is where something goes wrong. So we have 40 bits of stream there. Okay, cool. We added 32. So where's 72 there?
Is it worth printing out the unencrypted command and just making sure that it, like the array, like the first 70 bits of the unencrypted command, making sure that they aren't going weird?
Yeah, we can do that.
Because I mean, it's relatively simple.
It should be super simple. It's just somehow I'm messing this up.
Because I'm pretty sure the functions individually all work, because otherwise they wouldn't work for high-tag 1 crack, high-tag 2 crack 1.
Yeah.
Rather.
Yeah, for sure.
Oh, you're definitely resetting the tag, aren't you?
Yeah.
Yeah.
We do it up here. So false means that we turn it off there, and now we read UID again. So we were setting it from 0 all the time, and then we read the announce authentication there, and then we send over.
Where's the crack 1 then in this bit?
Crack 1 part is up here, is before.
Okay, but it is there. It's like we're in this
here you go.
function. We are doing it, aren't we?
Yeah.
Find the validity, blah blah blah. Oh yeah, but see the key bits. Hang on. Here's where we're going wrong. I know. Is it where we're going wrong?
I don't know. You tell me.
It's a very good question, isn't it?
It's a very good question.
It generates so hang on. So high-tag 2 find E page 0 command. That those key bits there, I'm guessing, does it make those key bits, or does it?
No, we get that from your when you go in here, go there, and you go here, and you do all this and loop-de-loops that you love to make, and you have all your guesses, and then you go to send E command there, and then you check that error response, which is, I don't know. I think I could take this away, and then you test it here. You test the, you see the key bits goes in here.
Yep.
EUID and UID sending, both of them is sent in. So we go into a test part, and then you do the cipher bits with plain bits. You sort it up to key bits, and then you take the read command, and then you send it. So you send this part here, 40 bits of it there, and then you get, if you don't get an error response, so you send that one again, 40 bits of the extended command that we generate here with key bits. So we got 40 bits of, here we got 42 bits.
Because we should, somewhere in that loop, we should keep changing it, shouldn't we? Is that not going to send extended encrypted command?
No, this is test of it. So we do it. Yeah. So this one's here, but we get 42 bits. Yes, we get 42 bits.
That's right. But then we just send a.
But the problem here is that we say that this is 40.
Yeah, we only send 40 bits because it has to be a multiple of 10, well, multiple of 5, technically. But...
yeah, but this is where we go wrong, isn't it?
But I don't think I think we're sending.
Okay, okay. No, when we're adding it, so.
Chaos lane is, we say it's 40.
Actually, we're using 40 bits, but we got.
We have 42. Yeah.
We got 42 bits, right? That's what we have. We're using 40 of them. Right. And keystring, what we're using is, yeah, that's how much we're sending and using of it, right? That's the keystring length that we're using.
Yeah.
Correct. When we're sending that there, correct. And then we go down here, it becomes nasty because now we add the new keystring bits to the ones in the stream where we used, but not of the ones that we have. Or is it supposed to overwrite those bits then? Here.
No, not over the first 40.
No, because that's what we're doing. Because we have 42 bits, and we're overwriting two of them directly.
We can overwrite. Yeah, we can overwrite those two. That's fine.
Is it okay? Okay.
I think it is because we've only used the 40, and then, I mean, there won't be any different. It won't. It doesn't. The fact we overwrite them, I think we're just overwriting them with the same value each time. So it's not really with what's there. You know, it's like it shouldn't. It should be fine.
Should be fine. I don't know. I'm gonna do that. I'm going for it. I'm gunning for it.
It's just all wrong.
It's all wrong, man.
It's all wrong.
It's all wrong, man. Oh god. What I'm doing.
Let's have a quick look back at this other code then.
I need a drink.
While I'm waiting for that, I'm gonna have a look at Crack2 and to see how that works. And then see
you don't remember this code anymore, do you?
I mean, it's a long time, so you know it's.
Come on, it's only been 7 years.
I've changed jobs twice since then. I went to Microsoft and wrote Sysmon for Linux for sysinternals, and then I left there and I now work for Iceman, who make eBPF, and so we make Cilium and we make Tetragon, which are kind of, so Cilium's like a Kubernetes routing and firewalling and load balancing and all very clever, really amazing, super fast networking for Kubernetes. And Tetragon is a security observability and network observability kind of solution for Linux using eBPF. So it's very low overhead. That's the idea. But we've been acquired, so at the start of next month, I'll be working for Cisco, as it turns out.
Damn.
Yeah, they bought the company.
Cisco, man, you climbing up the ladder.
I mean, it is good.
Is it? So here we go. I'm gonna do something that I haven't done for a while. I'm gonna return to the code that you wrote.
That's always a good idea.
Yeah, it is, isn't it? You can blame me after a while. But
yeah.
So this is the code that you wrote. Okay, almost. I have to fix those things back. So we enable all that stuff. We do this, and where's the offset? Okay. Now I need to check your code again, and we need to go into there. And I have to look at where is chaos streets. Copy.
And then read on the page. See. Hito to crack read page. Read page. Bit flips that in, encrypts it, and then just sends the command. So hang on, how does this Crack2? How does your Crack2 actually work? Using the code in this file, or is it?
Let's check it out.
Because I sort of feel like when it
I'm running it.
yeah, I know, brilliant. When it's done the crack, and then it does the read the pages.
It works.
But you don't have enough keystream to read 8 pages.
I don't, because
I think what I did on mine, what I believed I did on mine was I restart the tag thing and re-authenticate each time, and then you can use the same keystream over and over again.
Yeah.
But you appear to have the data from the pages.
Yeah. The thing is that I just reuse the same keystream that you take the first 40 bits or 32 bits. That's all you need, and then.
But that shouldn't work.
What is your code, man?
I don't know if it is. Is that my code? Tell me. Where now I've got to go to GitHub and have a look for the code.
You mean like that? What I'm doing?
Yeah, exactly. Was it R Fiddler, was it? Or was it an Adam Laurie or something? R Fiddler doesn't have any problem. If I Google R Fiddler, I think the GitHub link is like the second link. Oh, it's the first link. Better. Well done, Adam. You gotta trust. You gotta like Adam. So it will be in firmware pick32 R Fiddler X source. Right. Yeah, then it'll be in High-Tech2 Crack.c. And I vaguely remember this code. Right, so let's have I should be sharing my screen, and then you can see what I was looking at.
I kind of figure where you are at.
Yeah. That's that one there. That's the XOR. That's the read page.
Let me guess. You're here.
Oh no, you're showing the Fox marks. Oh yeah.
No.
Yeah.
No. I'm sharing yours now.
I am there roughly. Yes, that's right.
Yes.
That is. Yes.
This is your Crack2. That's why.
Yes, that is what.
Yes.
Oh yeah, kind of. I was a bit above that because I was looking at the read page function, which is and the NRAR pair. Oh right. So does your read page function take a? So your read page. Oh, just take the NRAR, right? But does it? But it doesn't use it, does it?
No, it's sent into a send command. To the send, it's not used in anything.
The send. Right. The High-Tech2 Crack sendy command.
Yeah.
That reinitializes
the crypto. Yeah.
Right. That does the get read UID and starts everything up from scratch. Right. Okay.
Yeah.
That's why. So that's why that works in your in the Crack 1. Yes. Because every time you read a page, it restarts everything, which is what it's supposed to do.
Yes.
Right. So in Crack 2.
Yes, it's called keystream in yours. High-Tech keystream, that's yours. That's the second one.
Yeah, then you
we do the same thing until the loop, and then the loop is there. So let's change the code to 40. K is off, and here's your send off. We're doing that with those 2 commands. And then you have your consume keystream bits, and that's the offset blah blah blah, and then it's extend, and then you write this there, and that's it. So if I go in here and I look at consume, this is where I need to modify things. You have consume next downwards.
I mean, the consume should work. You could probably leave it in, and it did.
Nah, I have to remake it so it fits your code. It's just that I changed it to work with my code. That's why.
Oh, okay.
So I would need to modify this. Let's see. There's num command plus that. It's okay. That's the same thing. Error response that I don't know about. We have send number of commands extended. Yes, here's XOR. Yeah, this is where you build up this 510 things. Okay, let's do that then. Let's go and do down there. This is, we do this. We do this. And all right, so.
Why did that all go horribly wrong in here?
What are you saying?
I'm looking at code and wondering why. So I clicked a button, it all went red, underlined red was red. I'm like, what have I done?
No.
Can I use?
Yeah. So that's it. Number commands int. Alright, this. We need to get out here. Int I, and I'm not going to do anything else with I, so int goes in there. Here you go. Use this one. Mem copy.
Oh, that's gone wrong. Right, okay.
Let's mem copy this one. Mem copy destination there. Now we got read page 0,10. That's the size of it. So we do that there. Now we XOR it. Let's see, 2 bits plus offset number of commands into this one. Great. We do this con length. This is my shortening. We are now sending the extended command here. Boop, 10 times this response.
Okay.
Okay, so this one is the correct as yours now.
Oh, conflicts.
Yeah, that's correct there. And now we're going for keystream extend. K offset, yes. What's the sign?
Yeah, I'm listening. By the way,
No worries.
Yeah, I'm just fiddling with other code in the background.
Don't worry.
Which I don't know what's going on. It looks like it's done, doesn't it? Yeah. Complete merge.
Well, it seems like you have some cool work you're doing now, by the way.
Yeah. It's quite interesting. So, you're basically writing C to run in inside the Linux kernel, where you can hook it pretty much on any function. So when that function gets hit in the kernel, it runs your code.
Yeah.
But in order for that to be safe, unlike kernel modules, for example, it has to be. You can only use BPF helper functions. You can't use like any random kernel functions, and you can only read memory you're allowed to read, and blah blah blah. So it's quite cool. You're writing like good quality C, trying to be really fast and efficient inside the kernel, and then in user space we have a whole load of stuff in Golang that sets it up, puts data in, pulls data out, looks at it, and so you can do clever things like you can monitor every packet going through your system. You can monitor every execution. But you can be really specific on things like every time something does a TCP accept or TCP connect, you can have code running and you can decide to stop that action from happening. You can kill the process. There's all sorts of things you can do with BPF. It's pretty cool. And then the idea of Tetragon was so lots of people have used BPF to make observability solutions. With Tetragon, what we did instead of what we did is we hid how it works and just gave you the ability to hook any kernel function and examine variables and make decisions and report it or trigger canaries or whatever without having to write any code. So you can just do it all in YAML, which is pretty amazing, pretty impressive. And then what I often work on, what I'm working on at the moment, is the enterprise version, Tetracon Enterprise or Cilium Enterprise for Tetracon, or Isovalent Enterprise for Tetracon. I can't remember what the actual name is. And what that does is it has extra stuff. It can run more and more code inside the kernel, be really fast. So yeah, it's pretty good.
Sounds awesome, man.
So it looks like the attack failed.
Yeah, but this is yours, so I'm not saying anything, but you know.
Yeah.
Yes. And it's all zeros, so that's also interesting to see. Tune of it. Okay, data plot.
But if it failed, you can't trust that data, can you? Because it means we haven't got anything there.
You can't trust any data, man. I can't trust this data either. That's crap. There you go.
Failed to get something broke, did it? Yeah.
There we go. Oh, I got some sniffs. Let's go to the end. Look. Here is your init UID off encrypted UID read command getting data out. So that works, right? And here we're doing the same thing and we're sending a little bit longer command, right? So this is the prolonged read thing, this part here, the prolonged one. Like compare here, but we do not get any answer.
So, you know how it works for 50 bits, but it doesn't work for 60?
Yeah.
What? Right, the probability that the first 10 bits of keystream we're using are beyond the first 40 of being correct is
small.
one in 1,024. Okay. So I think the first 10 bits are probably right because there's a lot of opportunity for those to be wrong if it was random. Yeah. If it's just whatever's in a buffer. So I wonder. Right. So so to add to that, in Crack2 in your code, the most you ever send is 40 bits or something, isn't it? It's less than 40 bits. It's whatever you needed to send a page, right?
Yeah.
Is it possible that the function that calls to do the TXRX has a maximum size?
Nope, there's no size there. I can show you why it's no size because I went through this several times. So send.
Okay.
This is me doing that over and over again. So we just take the TX we already have like there, and we're sending bits because and then we just loop it. And the size t's we go over all the bits that we want to send. Blop, blop, blop. It has nothing to do with not working. So this is just turning off bit banging. And that's a loop sending it all. So there's no limit for the sending, right? So then you go like, okay, for receiving then. Yeah. So receiving is down here. It's just after. So sending is okay. You look at the signal as well. Here it's waiting for something for the tag. And the tag doesn't answer. So the receiving fails naturally. So there's no limits in that part. There's no limit in that part. So this is working properly.
Yeah.
But
could it be that your timing falls is ever so slightly wrong, and so after 50 it starts to matter?
That's a good idea. That's a really good idea. I think all of these ones are accordingly, and yeah, well, You mean the bit banging? Oof, you mean like this? You mean that this one's here could be 4 and 8? Maybe it's too long, too short. Well, no. Well, we could add this one here. Should be between 8 and 10.
Because you control the field, it shouldn't really matter, should it?
No, shouldn't. Let's make it a little bit less. It's not like I can't play with it. It's easy to play. There you go. Let's flash it again.
Because my gut feeling is that if the first 10 bits of keystream that we've recovered from decrypting the UID
works.
And in actual fact, right, in Crack2, we do this anyway, I think, don't we?
We're doing the same thing over and over, but we only use this,
we only extend to a certain size, don't we? Because that's all we needed. But actually, it's worth having a quick. Something just failed, did it? So just have a look at the code again. The Crack1.
Well, he doesn't like it when I make it faster, I can tell you that.
Oh, okay. I said to find the page.
So it really didn't like that. So what we do that, and we do 10 instead, and see if that's better. And we run again.
Until we find a 10-bit command that sends. Oh, right, yeah. So that's what we do. So in Crack1, we find a 10-bit command that gives us back a 32-bit answer, and then we try them all, and we know that one of them will be paid. Yeah, one of them will be paid 0. So we eventually find that, and we test it by making a 40-bit command and expecting to get back a good answer and not a bad answer. Yes. And that's how you know that it works.
Yeah.
And so we know that we can send a 40-bit command and get back a 32-bit, and we know that the key stream is correct because it must match the UID in Crack1. So the receiving bit must work. I mean, it comes back to either we're using it wrong, or the sending function is failing. But the fact that when we send 50 bits, it works, that means the first 10 bits of the key stream we've recovered are correct, which implies that the decrypting the 32-bit UID after the 40-bit send is correct, which implies our key stream is correct up to 70 bits. I kind of think it might be in your TXRX where it's not happy. Because otherwise I don't have an explanation for why 50 bits works. Like if it only works at 40 bits but didn't work at 45 or 50, then we could say the key stream we recovered was incorrect. But the fact it works at 50 and we have a 1 in 1,000 chance of it working by chance.
Yeah.
We have to make the assumption that we've got the right 10 bits of key stream, and if we've got the right first 10 bits, then we must have the right 32 bits because we do the same thing for the whole 32. Or we've received it incorrectly, but previously we received it correctly because we knew it, because Crack1 works. So I think when we send it, the tag's not happy with what we're sending, so either what we've encrypted is incorrect, like the plain text,
or
the sending of the encrypted data is incorrect. I think that's kind of where it could possibly be.
Yeah. I can hear your missus and your kids.
Yes. No, they are somebody else's kids and somebody else's people.
Maybe you want to jump off the call and be socializing.
If I close the window, we don't have to hear the neighbours talking about us. Normally, what I do is I put on a very loud Doug Stanhope podcast, where he says things like "abortion is green."
Okay.
Because each individual, every baby you have is far more carbon than you could ever consume with aeroplanes or Lamborghinis. Every person you add to the world, So he said abortion is green. So and then generally they go inside, and then I don't have to listen to them anymore. But I can have my window open.
Okay. A little bit more than I expected there on a Friday evening, but all right, we can have it.
Hopefully, no one takes too much offense to that.
Buses, YAML-based eBPF rootkits.
Oh yeah, they exist.
Oh, we now. Have you been doing one?
No, but if you look at Linux Thor on GitHub, he did some work on some eBPF based rootkits, and you can basically. I mean, what we're doing with Tetragon doesn't really give you persistence, and while it does hide stuff and it can do clever stuff, there's not a lot you could do that's horrible with it with Tetragon in the form that it's in. But at the same time, you can stop programs from running. So if that's useful, yeah, you could stop programs from running. But yeah, there's no reason why you couldn't extend it to make rootkits. It's eminently doable. So where are we at? Are we? Is it? Are we?
Are we getting somewhere?
Exactly. Are we making any progress? I think we are, because I think what we can say is that it's if you use your code rather than my code.
No, this is your code. This is your code.
Yeah.
Yes. And I'm getting crappy thingy as well right now because I don't know why, but yeah, we're getting problems. So we're doing this. This is consume, and then this is extend, and then we print extended here.
This is the same problem, because what the consume is doing is basically extending the key stream, but it's consuming it as it extends. So it's doing the consume bit is extending the key stream all the way right up until you just need to do one more read. That's what consume is doing. And then extend is just doing the final read. Was the idea.
Okay, so this one is doing the final read, all right, and then this one is sending. But are you sending multiple, or you're sending a whole long? No, this doesn't make sense. So okay, so your code, you send a gigantic long read encrypted string.
Yeah, so what we do is we keep. Well, actually, no. I think it's just one read. Oh no, is it just one read after another? I think.
Yeah, because in the consume you read.
Number of commands times 10. No, so it's a number of reads, but the reads extend in the same sort of way, I think.
Yeah. I'm not. Yeah, I never got. Hang on.
Okay, so the idea here is, imagine you've got 200 bits of key stream.
Yes.
Or a better example, because we had these small buffers. So imagine you've got like 600 bits of key stream, but the most we can send is 510 bits in one go.
Yeah.
So what we want to do is do two well, we want to do two commands. We want to do one command that uses 510 bits.
But you're gonna read from that, don't you?
So we can because we've got 600 bits of keystream, we can make a 510-bit command.
Yeah.
Which is the read page 0, inverse, normal, inverse, all the way along.
Yeah.
XORed with 510 bits of keystream, and then you send that, and then you get your 32-bit answer back. So now we're at 542 bits of keystream has been consumed, and then you've got, so say you've got 600 bits, then you just do a read that will consume what you've got left, and then the answer is coming after right up at the end after most of the keystream that you've used. So you do the extend then. And the idea of it was just because I didn't have a 2048-bit buffer.
Yeah, I get it. So, I hear you.
So the consume is doing the same as extend. Well, consume is just using the keystream. Extend is doing the final read where the answer comes back and it's after the keystream that you already have. And you decrypt it to get more keystream.
So extend or no, consume doesn't read any answers back because you send this amount of it, and then
I think we throw the answer away.
And then you just okay.
Because we already know the keystream for that point, so I don't think we. So I think we might just. All we're trying to do is just like read and write in any form, anything. Just
yeah. We all know key bits. Yeah. So he does that, and then okay.
Which is why I'm saying. So
makes sense.
So what you could do in here, in my loop, you could take out the call to consume entirely, because you don't need to consume it. You can just.
Yeah.
I tell you what. Actually, hang on. What have we got? Imagine we've got 70. Oh, find a notepad to write on, which isn't my work notepad, because that'd be silly, wouldn't it? Maybe I must have a non-work pad around here somewhere. What about SnoopCon 2022?
Ooh.
You been to SnoopCon?
No, is it good?
Oh, it's awesome. Yeah, they give you free pads.
That's the best.
Year, are you? I think. Are you coming this year?
Sorry, what?
Are you coming to SnoopCon? BT SnoopCon?
No.
I thought you'd been invited to that. Oh, I don't know. Okay.
What are you talking about?
I don't know. There's a BT conference. Yeah, I thought they might. Someone suggested. No, maybe that's early doors. I mean, I'm not involved. Obviously, I've changed jobs twice since then. So
what are you telling me? You're telling me on a live stream I'm getting invited to a conference?
No. I can't be inviting you to a conference. Okay, so we've got 70. Imagine we've got 72 bits of keystream, right? Which we believe we have. We could do two reads. We could do a read.
Yeah. We can do that instead.
So we get 32 back, so that leaves 40. So what if we did a 10-bit command, right? And that would give us back 32. That would be 42 bits into the keystream. We'd still have 30 left.
Yeah.
So then we could do a 30-bit read. Yeah.
Yeah.
And that gives back another 32, which would then be so would be at 72 plus 32, and we'd have 32 bits of keystream. We would be extended, and it wouldn't matter then if there's a timing issue with the sending and the receiving, because we're keeping the command small. Maybe it'll work.
Yeah, maybe. Let's see if we add it with 10. I'm going to take this loop thing. I'm going to take away consume and extend again. And then I'm going to make a loop where I'm trying to make just extended by 10 bits by every time instead of 30 like we do.
Yeah.
Does that make sense?
You just want to do if you go into your so you ignore my code, just go back to your working your code. That's right. Let's use your code.
No, I didn't say that. Don't take it the wrong way now, man.
No, we're already it's already there. It's the best place.
The pain.
But yours was, we know that your code was getting us to 72 bits.
Yeah, well,
it just didn't appear to work, did it? Right?
Yeah, well, I managed to get 224 bits actually with your code before, but so now it didn't. So something's wrong.
How did that happen? How did that?
I have no fucking idea. It worked, not work, and that's why I ended up looking at the high tech 2 and saying in the sending and reading, and like there ain't any problem in there.
Oh my god!
Yeah, I know. Let's see. So let's see. Let's take this away here.
So where you yeah, we don't. Yeah.
This is yours. Okay, so let's see. We have 2 reads, one false and true. But I can do that away because we're gonna do this now. We're gonna do this. Here we go. We extend and we do all down here. What happened to that? This we can take away. Yep. I'm not keeping it. This is there. It's okay. And here. Oh. That's
okay.
All.
Right. So in here, where do we when we do the TXRX on line 580?
582, yes.
Yeah. So right. So if we make that KS length, we just change it for 10 on line 582. So we only send a 10-bit command. We're going to have to do 2 reads. Actually, you need to copy the code. What we're going to do is we're going to do. At the moment, it does 1 read and then it does 1 decrypt. Oh no, that'll be fine. No, it's fine. It's fine. So we don't care. Yeah. So if we do a read, make that 10. Actually, if you do a copy that because we're going to need that again in a sec. We want to do 2 reads, one after another.
Okay. What, are you going to use the response and sort it like that, or are we just going to ignore that?
So So I think let's have a look. So you do I don't know. So where do we want the? Just straight after it. I think just because I think we can just ignore what we get back. We don't care what we get back. We know it'll be right.
Yeah.
We don't care. I mean, later on you can check it, like with when you're being properly good. So make the second one like a 30.
Yep.
Yeah. So you've got 20, but if we make it 30. And make sure we have a
Just trying to see if we can identify the difference.
Yeah, that's a good idea.
Right. So I'm going to receive a response.
Right. So if we send 10 and get 32 back, that'll have used 42. We send 30, that'll have used the whole of the 72 we had. And then we get 32 back. So on line 603, what would our KS len be? Well, we don't want the +2, but I think on line 600 make that 32, I reckon. Yeah, so I reckon lose the +2 off that one.
Yeah, okay.
And I reckon add 32 because we've got 32 bits more keystring. I mean, the only thing we care about is does it get past the second go of the loop, isn't it?
Yeah, I hear you. Okay, let's try it.
Or do either of those 2 fail? That's the only thing we really care about.
Yeah.
Hang on.
Oh.
No, it's going to be wrong, isn't it? From the first. Oh no, because no,
it's okay.
Hang on, no, the first iteration of the loop will be wrong. Yeah, that's a shame. Right, so what do we start with? We had.
Well, we need to start. Okay, you want to send.
Because when we add the first time round, we want KS.
So this is the first. Okay, no, it's true. Look at this. This is fine. Yeah. First, we send 10 bits from the first command of extended, and then we send 2 more. So here we send 1 read.
This should be on the second iteration.
Yeah.
On the first iteration of the loop.
Yeah. This is the first iteration of the loop. Yes. And here we send 3 reads after that.
Yeah, but we can only send we've only got 40. So the first, right.
We got 40.
If we could have a little flag that says, "Are we on the first iteration of the loop?" On the first iteration, we could do what we just did normally.
Yeah.
And to get us, yeah. Let's just. I mean, I know it's hacky, mate, but let's have a little.
No worries.
A little beauty.
Little beauty.
Right. So if it's the first, let's just do a single.
All right.
KSLN read like normal.
Yeah. Okay.
Yeah.
Cool. Let's do
that. Yeah, probably there, isn't it? Yeah.
Yeah. No worries.
Yeah, that's looking good. And then we'll do the normal command. Oh yeah.
So this is first.
Let's whack that in.
How much do you want to send this one?
Make that KSLN, I think.
KSLN, all right, yeah.
Yeah, like before.
Yeah, and then we run 10.
Yeah, so we've done. So then we send 40. We get back 32. Right, and so on 609. That's KSLN. That's right. 609.
Sorry.
No, it's okay. I'm yeah. So I'm kind of thinking out loud anyway.
Yeah, I just jumped around, so it's very annoying for you. So when you talk about numbers and jumps, sorry.
That's okay. So the only other change I think we need, from my point of view, is at line 608, where you've got KSLN plus equals 32.
Yeah.
On the first iteration, we just want to add 30 instead of 32.
Right. So we're not going to do first there. We're going to change it here. So.
Oh yes.
Okay.
Yes.
If,
so we'll do. Yeah, that makes sense. Yeah, we're doing if.
Yeah. Because otherwise, I have already set the variable and.
Yeah, exactly. Yeah.
So what do you want in the second loop then?
So in the first, make it 30, and in the second, make it 32. Yeah, that's what I reckon.
There is.
Yeah, plus equals 32, and then first equals false is fine, and then and then okay. So logically, what's going to happen is the first iteration of the loop will be what we did before.
Yeah.
We got 40 bits. We send 40 bits. We get back 32. We decrypt 32 at the point of 40 into the key stream, which I think is right. We add 30 to the KSLN, which will get us up to 70. And so coming in, we'll have encrypted 70 bits of encrypted command, which is brilliant. And then we'll be sending a 10-bit command and getting back 32, and then sending a 30-bit command.
Yeah.
Oh, hang on. No, right, yeah. So we did there's something not the encrypted command. The second one's not going to be encrypted correctly at this moment because we need to. So when you do the XOR, we need to do another. We need to encrypt the command with the right bit of the key stream. So yeah, maybe we need like a temporary buffer or something. Where
do you want to have this one? What do you want to do with this one?
Yeah, so so if we had a temporary buffer that was like 30 bytes.
Yeah. We got it.
Yeah.
And you want to put it into, where do you want to put that into? You want to put that into...
Yeah, the target could just be the temporary buffer.
Wait.
Oh, no,
wait.
not...
I have to do this.
Yes. Yep. Yeah.
I have to do this first.
Aha. Yeah.
Encrypted temp. I have to do this because reasons.
Mm-hmm. No worries.
And then we got that. That's plain. So we are sending in etemp here, etemp, and we decrypt the CID, and we're doing kbits. Yes. So now, no, you wanted to put that in there, right?
Just slap that into temp. Yeah. And then we'll use.
Yeah. And now you need to XOR in the next.
Yeah. So then we need to XOR that, don't we, into with the command. Do we? Hang on. What are we doing?
We have to go +10 here, don't we?
No, what we need, is it the UID we need? No, we need, yeah, so sorry, right. The temp buffer needs to have the encrypted command. That's what we need. So actually what we want is, we don't need the response.
Okay.
Sorry, I was misleading you. I was just saying yes. Every time you did something. I don't think we need to care about the response at this point. We can just trust that it's all okay.
Okay.
Because we already have the key stream.
Yes.
And this is like the second iteration, so we've got 72 bits of key stream.
Yes.
So what I think we need, so we need the temporary buffer, and the temporary buffer only needs to be 30 bytes. The tump, and we just need to do the XOR, so we can lose. Where are we going here? Well, oh, false.
It means that it keep the field up. You want to keep the field up. You want to send directly. No, you don't. Do you want to remake this, or what?
No, just say.
Because you want to send a new read command that is encrypted with the leftover. Right. So you. Okay, I think I get you. We have used 10 bits of crypto stream.
And received 32 bits. So we've actually used 42 bits at this point.
Yeah. Plus 32 for the response. Yes.
Yeah.
We have, that's correct, 72 bits.
Yeah.
To play with. So actually we can't send 30, we need to send 20 man.
You've used 42, we've got exactly 30.
Yeah. Okay. Great. Yep. Perfect. So and we want to keep the field up. We want to continue the crypto engine on the card. So that's why the field is up here. That's why we keep it doing. So now you want to send a new read page, and you want to encrypt it with the next upcoming XORness. Yes.
So in that XOR command, TMP is the target. That's fine. One of the things we want there is going to be C2X command. So because we don't need those etemp. The etemp.
Yeah, we don't need etemp, right? We don't.
We don't need that. We don't need the response. We can lose. So what? That wants to be the unencrypted command. So just X command.
Okay.
And then we'll put some. So you just take out the E underscore at the beginning. I think. Yeah. Yep. And then where you've got C2 UID, that wants to be C2 key bits plus
42.
42, I reckon.
Yeah.
42 bits in. Yeah. And then it won't, but we only want to do 30.
Yes. We only want to do 30, right? So this should be dope, and this should be dope. And yep. And then we will send temp.
And that one's 30. Right. And then when we send, we send temp, and that's 30 bits.
Yeah. Right. That's what we're doing now.
That's what we do.
Yeah.
Oh, can we? And we've got some printing those out if it fails. Good. Okay. Yeah. So theoretically, this might work.
Yes. You're absolutely right.
For the second iteration, it might fail at the third one, but at least we then know what's going on.
Exactly. You're completely right.
I mean, it might not it might not fail horribly. It might just sit there continually doing something in a loop forever. But I think you can stop it with the button, can't you?
No worries. So I can. I added a button press to jump out the while loop. So no worries. No.
Okay.
Yeah, we could have broken it, but because I expected it to fail here, so that's good. But it worked because we got 32 back. That means
failed 30. So the sending the 30 bits didn't work.
Yeah, it's not really true because we got 32 back.
Oh. Why is it saying
no,
that?
we got 32. So we got 32 back. Why does it say it failed?
Oh, that's a good question.
That's
how else?
Wait. It's embedded. So it's embedded. It's embedded. So let's not make these mistakes again. Let's make sure that it's zeroed. TX length is maybe not pack bits. Yeah, it's not zeroed.
Okay, so maybe we haven't actually got 32.
Yeah, this is classic fault behavior on embedded devices. What I noticed is that if you don't zero things out, don't assume that the memory is cleared.
Oh yeah.
So let's see here. So doing that, we should have gotten this. Wait. We should also. We're assuming this worked, by the way.
Well, we'd have got a TXRX failed 10 if that had failed. So you're just going to print out. Yeah, 10. Sending 10 equals. Let's
say if it's larger than 0.
Yeah.
We failed, so there's no use of sending anything else. We can just exit the whole thing. Break because it didn't work. And db string. All right, let's go and let's do this again. Let's flash it and rearrange it. For you of other viewers there out there, if you have any questions for Kevin, he's the mastermind of implementing some of his crypto stuff. I'm happy to see he has the same approach as I am.
Absolutely.
Brute forcing over and over and over.
Yeah, it's the only way forward.
Yeah, it is actually.
All right.
Right, we got an answer, so that's good. Right, so this is perfect. We got an answer after 10 bits.
Okay, and then we did the next send and 30, and we got 0. Okay, yep. So what if we just send 10 next?
Yes,
30?
I think that's an awesome idea. How about we send 10 more? All right, let's do that. Because it doesn't matter if you do 30 XORs because we are sending 10, right? Yeah,
exactly.
All right, cool. I like this. I like it. Sounds like a plan.
Oh, what? Yeah. I'm gonna have to bail. I'm gonna have to bail because I've got
no worries, man.
Because I've got dinner lined up.
Yeah, me too.
With my wife.
Do that stuff. Yeah, give us some love and huggers. Hugs.
I mean, we literally. We have a taxi booked, so let's see if this works, and then I'm gonna have to leave you to it.
It failed.
It failed.
Failed.
Okay, so the sending. Let's look at the code then. So the sending of the second 10 doesn't work.
Nope.
Is there any good reason why that doesn't work?
No. There are no good reason why it failed. Shouldn't. But I need to check this key bits and if there's a limit in the XOR or something. Because we got uints.
It's there. I'd never thought of checking that.
So it's a uint, so that's a length, and we're taking a size 10. So let's just go to size T. I don't like this stuff normally, but just do it because type confusing shouldn't be, of course. And you saw it, right? You have a constant source and a pad, and it's nothing special. And you have a target, right?
There's nothing special.
No. It's bloody normal, isn't it? This works.
It should be an S size T, by the way.
What is that?
It should be no size. Not signed. No, just size T. Yeah, sorry.
What are you talking about?
No, I thought size T was signed.
Yeah. Okay, I hear you. Yeah. No. It's okay. We could use an int as well, but since we're using since n is a size, and I won't have any type confusion.
Yeah. Okay. Well, I will have to leave you, and I hope this has helped in some form or other.
It did. You did well.
Just goes to show how hard it is to write code for the Proxmark.
But isn't it plus 10 here?
Where?
Second. And the second one. Isn't it plus 32 is starting from the bits?
Yeah, maybe. So if on the
because we consumed 10 before up there.
Yes.
Shouldn't it? No, maybe that's wrong. No, that's
maybe.
Wrong.
Oh no, hang on. No, it's how many we've consumed. We don't need the 42.
How many
do need the 42. Yes, we've used 42, and then we've used to keep plus 10.
Shouldn't it be plus 10?
Yeah, I think. Yeah,
because otherwise we were using what we were.
So we're saying from the 52-bit into the key stream.
But we don't have 30 there. That's a little bit annoying though. So that's kind of annoying. So
no, it's 42 because the 10 that was 10 plus 32.
Yeah, okay. It's
42 was the right number. That was right. It's 32 plus 10.
Yeah, like that. Yeah.
Yeah.
It's confusing when you write stuff and you go like, where does that 42 come from?
Yeah, well, exactly. It's kind of fun though.
Kind of fun 42, yes, it is.
So that.
Of course, it failed. It should fail. It should.
Yeah. Okay. Right. Well, I shall leave you, ladies, but hit me up next week if you're still struggling with it, and maybe we'll chat again.
Thank you so much for answering my questions. Thank you so much for jumping on a call, and thank you so much for joining the stream and everything like that. And man, I hope that you have a good weekend.
And you, it's always enjoyable. I really thought that was going to work.
We might. Hold on, give me some more time, and I will do it. Have a great weekend, man, and just take care.
Excellent, and you. Bye.
Bye. Now I have to take off the music again. All right. We had a question concerning Chameleon Ultra. EM tags, low frequency. Is RG planning getting support for more tags? They are actually. That's the latest gossip. I spoke about that in the news some weeks ago. So what I know is that is a developer working on adding the LF tag functions. Should be actually. I haven't looked at that repo for a while. Some commits. Some commits. Logging 1st of April, 3 weeks ago. CLI. Okay, so yeah, I expect to be more. Oh, look, LF test rollbacks. 17 January. That's nothing. This is main branch. Okay, stale. 6 months, 3 months. Yeah, that's nothing. Sorry. But they are, what I heard, working on it. Yes. Let's see what happens. Oh! I see. Tech security tools is here too. Janis free. Well, I haven't heard anything from .NET, so sorry, I can't merge that one. Still icon a dumping clone tag. Fuzzing, yeah, well, if people like to work on things, there are a lot of issues. So feel free to, you know, jump in and do things, of course. Right? Sheldrake, Kev2 is a pretty awesome guy. If I haven't seen the videos of him, YouTube, of course. Pretty cool dude. Yeah. He's doing a lot of things. I did a talk about BPF. So. This is for buses. He likes this.
I'm Kev Sheldrake. Thanks for coming along. I'm going to talk about...
That's him.
Detection and blocking with BPF via YAML. And I'll talk about what...
So you guys can enjoy all his talks, because he's quite good at it. Trying to build a web app using the SDK Tycoon build. Cool. Well, I only know that we're working on LF support. When it's gonna be done, I have no idea. That's as much as notice I can. And right now I need to talk to some of my kids that come home. So we'll take a little break and I will be back soon. All right, back to go. No time for the wicked. No time for the wicked. So it's awful silent in the comment section, please. Occupy buses. Are you gonna do a talk, by the way, buses? Or will you leave that for the other dudes? No, 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 no. Broadcom acquired VMware. What the hell? Okay, you must activate your Broadcom support. Damn it. Why is always this things? Alright. Alright, let's see. So 10 works. What about if I send 10? Did that work? No. Why? Mm-hmm. Mm-hmm. Mm. So we're getting 30 of them. Right. String. That's correct. That's correct. So plain is okay. Alright. How about I print the key stream as well? Key stream. All right, let's compare all of those one. Zero zero 1 1 0 1 1 0. Looks right, doesn't it? And if we do like this, where's the num? And take that. Boom. Oh. All right. Right. So if I XOR these two up here, I should get one B, 3 C4. So yeah, that worked. So worked. That is correct thing. Nothing wrong. Nothing wrong. Sorry. Okay, why does this not work? Mailing them golden. Right, I need something. Right, so by the way, we did that. We can compare. We can compare. Good idea. We can compare 30 bits of encrypt command up here, plus 10, with offset from this 10 there. So this and this, no, this and yeah, do like this, it's easier. So these two should be the same. Excellent, excellent idea. Let me know if you ever converted code. Oh, what? Say what now? Whoa, what happened here? What is going on? What is going on? Why did that fail all of a sudden? 1000 US. Okay, are we having anything? Yes, we do. Yes, we did. And put it in there. From that one into that one. Okay, cool. God. Why do you make stupid decisions like that? Need to keep the fill up. Otherwise it will not work. Obviously. No, didn't work. Why didn't you not work? That even didn't work. Okay. Mm-hmm. Can't even do that. Can't even do that. That worked. Right. Hmm. Hmm. Let's print it. The glorious work of figuring shit out. Oh. Does anybody have a good suggestion for some good coding music? Huh. Lovely. He is remarkable good at finding bugs. Alright, so we got an encrypted response. We exored the UID to get the crypto stream out. Okay, let's print that one. Right, cool. Boom, boom, boom. That's what it says. He uses 30. I don't get it. Oh, let's do that. And here I thought that you wanted to join the call, Gentle Kiwi. You know, jump in and say hi. Right, still working. Don't have to do this because it's just annoying. Key stream. Great. All right. So we got that. Yes. So now I have key stream 72. Right. Great. Now we spent. After sending that. Mm. 10 for read. 30 for encrypted. No. Send off. What does you do? Get you ready. Okay, let's see. Not do that. Go there. Here we go. Get you ready and do it again. Okay, and then you send an error because it's done. Okay, we have that here. This is what we do there. Okay, cool. Then what? I need as this consume the large verb, but it's not, so this is the first time. He does extend. And extend, he creates. Well, there's no offset in case length, that's the starting point. Zero. There's no offset yet. Hi MX. Yeah, well, look, Benjamin says hi as well. The gentle Kiwi. I hope you have a good evening tonight with your extended family. I'm doing the hard work for you. Sitting in front of the computer, trying to fix all the bugs that you find. I don't know why, but you always find bugs. It's because we make shitty code, but that's a different story. Your pleasure, yeah, you love that. It is all for you, yeah. Benjamin. You know what? I think I need a drink for this. How about I go and take a drink and come back? It's Friday evening, I deserve a drink. It was really funny having Kev on. You should have listened to him, he was great. Such an awesome guy. Really awesome. So this doesn't even work now. Mm-hmm. Failed. Everything fails right now. I think I'm going bananas now. Okay. What on earth am I not doing at all? What am I doing wrong? Everything of course. Qubits. No. Did he generate it from scratch, all those qubits? Extending keystream, yeah, okay. He did this. It's 0 the first time. That's the commands. So. And then he sends that and sends the size of that, and that's it. He adds the newly found salt to the end of that one there. And then he says it opens up. Totally makes sense, doesn't it? So, first command we sent. Ah, yeah, that makes sense, by the way. That makes sense, by the way, because I didn't XOR it. Oh, thank. XOR. Yeah. How about I do that again? Shall we? How about we do this? Case length. Alright. No. C2 case bits. Okay. Alright. So that should at least take care of that one. keep my fingers crossed for this. That worked. Alright, cool. That should work too, because we just changed it. Works. Great. Great. So now that we send 10 more the second time around, it doesn't work. Why is that? So according to this, is that you can actually overwrite the recurring key streams. How is that even possible with that? We're prolonging the key streams out by those. Because this doesn't work. Okay. Timing issues. Could be that. Could be timing. Timing can't be timing. Let's print this one again. Let's print that with there. Because these are the latest ones. Imagine the guys who did this 12 years ago. Just coming up with this and doing it in Proxmark and figuring out how to perform these attacks. And, you know, Jesus Christ, the struggle. Must be spending weeks, months on this. Most likely did as well. So yeah. All zeros. Key space. Look. Why is it all zeros, you say? Should be that, shouldn't it? Isn't that funny? It's not funny because I'm taking the wrong thing, isn't it? I should take plus 40 because I am way stupid. If someone ever asks me if I ever get tired of seeing that logo, always. No. Lovely. Yes, but I see it quite often when I do this stuff. Alright, look. Key stream matches. Key stream is a match. So the recovered data is not correct. Te, tack. It's the same. It's the same. Always works. Wow. Wow. What am I missing? Wow. Same data. Great. Great. It's worked. Mm-hmm. You know what? I could actually generate the key stream for this one. Because I have, this is what I control, this and this. I don't have a key stream anyway, so it doesn't matter that one right now. Because we're manually taking it from here. Now we do that. Start all over. I don't think we need to do this. Let's see. We should not have to send the get UID twice. That's just a waste of time. Should be able to just turn off the field. Alright, this works. Which it should, of course. So that one works. So now we're going here. We do this again. Take the next 40 bits. Add it to here. And then we send 50 bits. That's 10 more. And here we send 60 bits. No, oh, that's silly. We send 60 bits. That was stupid. Oops. So the 40 works well, and the second time around, we're trying to do that. And if that works, we should be able to send 70. Here. Is it a sending thing? Okay, let's assume it's a sending thing. Let's go in. Sending doesn't do jack shit. Go for receive. Count periods. Tick, 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 tick. That's what it does. Is there anything that is outside of this loop? No, it's just a normal loop. Is it this that overflows? Max false false, okay. A timeout. Let's increase the timeout to 200,000. Oh no. Doubt that changes anything. We don't log it, so that doesn't change. Periods, blah blah blah. We don't log it either, so yeah. Great. Or not great. Have nothing to do with us. Let's go for it. Nothing. Okay. So it's not there. It's all lovely here. Nothing. And go for LF, high tag, info, LF, high tag, read, high tag, crypto, all works, great. And we can do a Crack2. Nothing changed. All works. Great. Awesome. Awesome. Nothing changed anything. Still, this doesn't work. Okay, sending then. Sending. It's not turn on, so false. Not turn on. Start duration. Nobody cares about values since the external length is send bits. Okay. Wait periods. We wait before we're sending a command. It's a normal timeout, but we're doubling it. We do this. We go in here. Size. We're sending this. Boop. That's it. And then we do this. And we send a stop. Okay, maybe the stop is too slow. Should be larger than that. Okay, let's increase it to... Just because it's just a number right now. Everything is just a number. It's all about a number. You didn't like that, did it? Interesting. Info. Nope. Like that. Alright. Now, 34 then. Is there a time drift in our clocks? Oh, interesting. Is there a drift in our wait periods? Is there a drift? No, it's not there. Tick, just ticks. There's no falling over, right? Maybe could be overflowing sometimes. Could be. Alright, let's see if it works better. Oh, better. Could be that. Pierce the size. And we return a size. Well, let's average. Oh, split it by 16, 32, okay. Okay. It's nothing like that, is it? No. Here's not bigger than size match. Nope. Nope. No, So his timing is okay. Nothing happens here. Maybe better. I don't know. Nope. 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 Nothing. 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 Nothing of this is of any consequence of this. 30, okay, for one and that. Let's see. T wait periods for a 1 and a 0. Oh, well, it doesn't say anything. 109 is that, 90 is that. T. Okay, here we go. No. So here, T1 wait is this. 190 is wait 2. That's this one up here, so that's okay. Data doesn't say how data is. 5, 10, 20. Read page. Read mode, no. Public mode, no. There we go. Low, high, low. Okay. Start off. Power up. Wait, max. Read page. Right page hold. Memory map. Blah, blah, blah. Where's rest? I want this. Config bytes. OTP, yay! I wonder if you can tear this one off. However, it looks like write only is when it sets to 1, and I think high tech tears to FFF, so I don't think you can. Would be cool though. Okay, back again. Flux capacities, new bit length. Yes, data rate. Okay, modulation. Thank you so much. Here, 1 and 0. Here we go. Low. All right, let's go up. Set F12. All right, let's go. Low field time is, what is low? It's this part. Okay, so the low time is 8 to 10, which we tried. Depending on antenna. Okay, cool. T1 is 8 to 22. Let's see, this is here now, send a bit, right? So we have T0 is 20, so that's middle. T1 is 30, so a little bit higher up. There was minus 10. So this is 30, that's 20. That doesn't work at all. Should really not be like that. Shouldn't be like that at all. Should be 8. EOF should be larger than 36. Okay. Larger than 36. High field to stop condition. Okay. So low and high pulse. Low and high pulse. Low and longer. Okay. Cool. Oh. So we'll always do a low that is 8 periods. Basically what we're doing there. Yeah. This one. And what's this? Okay. What is this? So 2,000 times that is now going to be a 32, 6,000. Yeah, maybe. So we do this. So we got all that in into that one. We add up all the things that this took, and then we're doing this. But this doesn't make sense. This does not make sense. That's the switching time, right? What does this do? Why do we wait for stop condition? First we sense all the bits. Hold on. So this is a bit. That's a 0, that's a 1, that's a low phase. The high phase is yes. No, we sent that. We should have a stop, which is a high field, which is this. Or why do we do this? Ah, it's this. That was not very clear. It's this. We do that for a low. Yes. Okay, cool. That was not clear in the documentation. Why couldn't they say what the hell this is? Okay, so we have a low for that one and then turn on for that one. Okay. Which is larger than 36, but if we make it larger than 36, it starts to complain. That's interesting. 1, 2. Some frame bits. Yeah. But we add one of those in there because if we're going to send long things, we might as well do it. If you're going to send long frames, we need to do this. It'll take 2.5 seconds, but anyway, so. What if I do before? At least I have it, so yeah, okay. So that's the low. It is the end of EOF, end of frame. And EOF. Yes. Just for the sake of double checking things. Let's do. Okay. Let's do it again. Let's do it again. Let's do it again. So far, so much true. Now, let's test it. See if I have. So I have cipher bits. I don't have it. I have airplane. And I take this here response and save it. So Yeah. Sorry about that. Okay. No, sådär. Jag måste göra så här. Måste jag göra den först också. Och sen så gör vi lane. Nu. Now. We are rolling. Not 42, but 42. How can I do 42? Can't. Where was 42 from? 32. 32. Thirty-two. Mm-hmm. Mm-hmm. Yep. And yep. Let's see them. Okay. Alright. Alright. It's been a long time trying to figure this one out today. Thank you all for joining. I hope you all have a great Friday evening, and I will take a break because my brain needs it. I do enjoy Kevin coming online. With that said, have a good one.